In this video, we will be learning about an extension to the concept of functions, that is, the inverse function. We'll start with some notation, its intuition, and then a general method of finding an inverse. An inverse function is the function that maps its image to its object. It is basically the exact reverse of a function. It is denoted as follows, and read f inverse of x. And since it does the exact opposite of f, using them one after another has no effect on our input. Remember that a function can only have one image, so the inverse to a function only exists if the original function is a one-to-one type of relation. This means that if the original function is a many-to-one relation, then many objects will be linked to the same image, so if you reverse it by taking its inverse, the same object will be linked to many images, and it will no longer be a one-to-one type of function. Basically, to find the function's inverse, we want to take the object of a function and express it in terms of its image. Here are some examples to illustrate my point. It is common knowledge that prices in different countries are expressed in different currencies. Suppose you wanted to buy an iPhone X from the US for $999. How much ringgit would you need, assuming the current exchange rate is $1 to 3.96 ringgit? That's pretty easy, because its price in ringgit is just a function of its price in dollars. Turn the question around and imagine that you now have 5,000 ringgit, and you're wondering whether you have enough money to buy an iPhone X from the States. It's also pretty easy to find out, because you just do the reverse calculation. At first we were interested in PMYR, but now we are interested in PUSD. So we just rearrange the equation with PUSD on the left side and everything else on the other. In other words, you just need to switch the object and image around to find the inverse of the function f. And notice that you'd have enough money, yay. Though I would note here that with 5,000 ringgit, probably won't be able to get your hands on an iPhone X, as they are sold for 5,149 ringgit in Malaysia, so don't get it. No, I'm just joking, but have a think about why that is. Another example is one you'll definitely be familiar with. Calculating your total score for an exam. Consider an exam with two papers, 100 marks each with an equal weightage toward your final result. And let the grade for an A star be 90 marks. Say you got 85 marks for paper 1 and 97 marks for paper 2, your overall grade will be a half of 85 plus a half of 97, which will be 91 marks, and an A star for you. Now imagine that you are taking both papers separately, with 2 days in between sittings. You've just finished paper 1, and you're confident that you've scored 87 marks. How much would you have to score in paper 2 to guarantee an A star? Now you have to do a reverse calculation because you want to find the value of P2, which will generate a total mark of 90. So you just rearrange the equation, put P2 on the left and everything else on the right, to find that you'll need at least 93 P2 marks to guarantee an A star. These are all examples of inverse functions, which is, well, a fancy term for doing a reverse calculation. So here's the general way to find an inverse. Consider a general linear function fx equals ax plus b. Since we want to find the value of x that generates a given value of fx, we just need to rearrange the equation to solve for x. Here we call fx w because it will become our object later on. Once we have an equation which generates the value of x for any given value w, we notice that this actually represents the inverse of f. So instead of calling it x, we now call it f inverse of w. But then, since w can represent any number, it is exactly the same as calling it the f inverse of x. One final thing I'd like to add is that our choice of domain also affects the existence of an inverse function. Remember that for an inverse function to exist, the original function has to be one-to-one. There are some one-to-many functions that behave like one-to-one functions, for sections of their domain, such as fx equals x squared. It has no inverse for the domain R since it is one-to-many, but it has an inverse if we specify a domain of all positive real numbers R+. Well, that's all for this video. Remember to stay curious and always follow your dreams. See you in my next video.